For question number 5, it's clear to me that you're going to have some issues, right? What you need to do right away is to always start by completing the square. Now, it says here, basically that we've got an equation for some guy's height, and he's jumping off of a very high place, basically a springboard. And our equation is h equals negative 5t squared plus 6t plus 3, where t is the time in seconds after he leaves the springboard. Now, it says here, we're going to go and try to find his maximum height. So remember what I told you. You always have to start by completing the square, which allows us to find the vertex form. So let's do that. Now, after the first 3 lines, you'll notice we've got our bracket here. Now, notice the b value in the bracket. It's negative 1.2. So we're going to go negative 1.2 divided by 2 squared, which ends up being negative 0.36. So we're going to add 0.36 and subtract 0.36 to our bracket. Now, when we go to the next line, we create our perfect square by pulling out the minus 0.36. And what we're going to make sure that we do is we're actually going to multiply the 5 times the negative 0.36 to get plus 1.8. And then we're going to add 3 to that as well. Continuing with our perfect square, we end up with negative 5 bracket t minus 0.6 to the power of 2 plus 4.8. Now, some of you guys tend to forget that you had to get the plus 0.18 by taking basically negative 5, and we're going to times that by negative 0.36. And that gives us our plus 1.8. Now, that represents our equation for the height in vertex form. So, if you think about it, the vertex is just going to be, well, opposite whirl for the inside part. So we get 0.6, comma, 4.8. Now, you need to remember what each of the variables are in this equation, and the 0.6 is going to be just t, and our 4.h is basically the h value. So basically, based on our original calculations, we know that a is negative 5, so it's going to be a maximum type problem where h is 4.8 when t is 0.6. Now, this first part asks you what the maximum height was, so that's question A. And question B is answered by t equaling 0.6. So it says, for the B, it says, how long does it take him to reach the maximum height? So technically, we can answer both of these questions now. So, now we can say the maximum height is 4.8. Now, you have to make sure that you look at your problem. It says h is in meters, so we have to say 4.8 meters. Now, for part B, let's do that now. It says, how long does it take him to reach the maximum height? Well, it takes him about 0.6 seconds to reach its max height. So you're going to say the max height happens when the time is 0.6 seconds. Now, in order to do part C and D, part C is asking you, how long does it take before he enters the water? So you need to realize that you start above on a springboard or a ladder. That means eventually you're going to hit the ground. Now, you need to remember that h is 0 when you actually hit the ground. So we have 0 equals negative 5t squared plus 6t plus 3. So you try to find, we try to do difficult factoring on this, and it doesn't work. So we can't use difficult factoring or simple, so we're going to have to use the quadratic formula. And we have a is -5, b is 6, and c is 3. So I like to calculate the discriminant first. So I get b squared minus 4ac, and we get this, and we end up with our total to be 96. So that means we're supposed to have two solutions. So let's do our calculation. So instead of saying x equals negative b plus or minus all that junk, we say t equals that. And now we get t plus or minus the root of 96 over 2 minus 5. And then what we're going to do is we're going to split that problem up into two parts. One where we have negative plus root 96 over, well, 2 times negative 5, which is going to be negative 10. And then our other solution, or t is equal to negative 6 minus root 96 over 10. Now, calculating the first one, negative 6 plus root 96, do that on the top, and then divide by negative 10. And you're going to get approximately negative 0.38 seconds for t. And notice I'm just going to highlight this. So this is one of our solutions, one of our things that touch the 0 axis, the x-axis. Now this one here, negative 6 plus 96, root 96 over negative 10, that is going to give me approximately 1.58 seconds. So that is what t is in this calculation. Now, I'm gonna tell you something. You know that time, we can't go back in time. So guess what? This one is impossible. We can't use that as our solution. So this one here, because the time is greater than 0, is the time it takes to hit the water. So we're going to say, so he hits the water at 1.58 seconds. And boom. So it's important to recognize that when we're doing these height calculations, anytime they say, when will they hit the ground, when will they hit the water, something like that, say, we always are looking for when the height is equal to 0. That's why we set h equals 0, and we solve for this. Now this would have originally given us an intercept form for our calculations, but guess what? It can't factor properly, so we have to use the quadratic formula to get our actual answer. Now, anytime we're dealing with time, any time that's less than 0, we say that it's impossible and we're not going to use it, so we always end up using the positive time. So for the next problem, what we're going to do is we're going to take a look at question D. Now, you need to realize that when we start, we're starting the jump. So we're on a board and the time hasn't started. The clock literally has not started. So we're going to say that the time is equal to 0. Now, when we do that, all we're going to do is start with our equation, negative 5t squared plus 6t plus 3. And then all we do is we simply substitute t equals 0. And basically what we're looking for is we're just needing the initial height, the starting height, right? Now, the starting height happens when our time is equal to 0. So in essence, we're just going to substitute t as 0 into our equation, or use the rules that we learned from before. Anytime we have something in standard form, we just read the final answer off. Our final answer should be 3. And h is in meters, so we're going to say it's 3 meters. So therefore, the board is about 3 meters above the water. There you go. And that is when the time is 0, or when he's on the board. We're good. So I know this problem is kind of hard, but you need to realize that you can't shy away from them. You need to find some way to use what we have learned. Good luck, kids. Continue with the rest of the solution sets.